Hello everyone, in this video on operating system, we will see the outline of this video is round robin scheduling algorithm in operating system. We will see an example with table and Gantt chart, and we will calculate the average waiting time from the given information of arrival time, execution time, service time, etc. So let's continue. Moving on. Round robin is a preemptive process scheduling algorithm, right? Round robin scheduling algorithm. Round robin is a preemptive process scheduling algorithm. Each process is provided a fixed time to execute. This fixed time is called the quantum, right? It is called a quantum. Once a process is executed for a given time period, it is preempted, right? Once the fixed time is over, then it is preempted. Preempted means to swap it with other process which executes for the given time period, and then that one is also preempted and swapped with other process. Context switching is used to save the context of the preempted process and to switch between the processes. Now what is context switching? Context switching means you switch the context of different processes and you save the context of one process and execute the other process. Now here is a Gantt chart. This is a Gantt chart of the example which you are going to see. Now first let us see the table of this example. This is the table given. P0, P1, P2, P3 are the processes. Their arrival times are 0 second, 1st second, 2nd second, 3rd second. Their execution time is 5 seconds, 3 seconds, 8 seconds and 6 seconds respectively. Now what is service time? Service time is the time at which service is provided to the process. It is the time at which the processor is assigned the process to it for execution. Now here the service times are multiple because since the preemption is done to this process, hence it has different service times. Now I will explain the Gantt chart and it will become more clear. P0 executes from 0th second to 3 seconds. But as you can see, its execution time is 5 seconds. So its execution is not over. But we have swapped the process with P1, right? P1 continues to execute for its time quantum of 3 seconds, that is from 3rd second to 6 seconds, and it continues to execute for its execution time of 3 seconds and it is finished, right? Because its execution time was 3 seconds, hence it is finished. Then P2 comes and executes for 3 seconds. Now what is the execution time of P2? It is 8 seconds. So 5 seconds are still remaining for it to execute. But since the time quantum of 3 seconds is over, hence we switch it with P3. P3 is from 9th second to 12th second we execute the P3. Now what is the execution time of P3? It is 6 seconds. Since only half of it has executed, hence we will execute the P3 later, but now again the P0 comes into picture, and since its execution time was 5 seconds, hence it is executed for 2 seconds more. Since from 0 to 3rd second it was executed here, and from 12 to 14th second it is executed here. So 3 plus 2 gives 5. Now again P2 has to execute. Since P1 was finished execution, we jump to P2. Since P0 has executed completely, we don't swap it, we terminate it and we assign the processor to P2, which executes for another 3 seconds. Since the execution time of P2 is 8 seconds, hence it is still not finished. 3 seconds it has executed here, P2, and 3 seconds it has executed here, P2. 2 seconds are still remaining. Now P3 executes for 3 seconds and it is finished. Since its execution time was 6 seconds, and hence it is finished execution from 17th to 20th second. Right? Half of it was executed here, 9th to 12th, and half of it is executed here, 17th to 20th. Now coming to P2. P2 has only 2 seconds remaining, so it continues its execution for these two, 20th to 22 seconds. Right? Let us see the table again. P0 starts its execution at 0th second. It is provided service at 0th second. and also at the 12th second as given in the Gantt chart. P1 is given the service at 3rd second and it finishes execution in 3 seconds. P2 is given service at 6th second, 14th second and 20th second. P3 is given service at 9th second and 17th second, right? I have explained you why there are multiple service times, since they are preempted after every 3 seconds. Quantum is 3 seconds, hence there are multiple service times for them. Now wait time of each process is as follows. How do you calculate the waiting time? It is calculated by service time minus arrival time. This formula makes sense because the service time is the time at which the processor is given to the process and the arrival time is at which the process arrived in the job queue. Since if you subtract these two, you get the waiting time. Now what is the waiting time of process P0? Let us calculate it. Service is provided at 0th second and arrival is also at 0th second. So 0 minus 0 gives 0. Now service is provided at 12th second and it is finished execution. Now this 0th second, I will show you the Gantt chart again. Since P0 continued its execution from 0th second to 3rd second, 0th second to 3rd second, hence we calculate and it is provided it service it again at 12th second. You can see here P0 is provided service again at 12th second and it finished its execution is 3rd second, hence it returned to job queue at 3rd second, but it started again at 12th second. So we subtract 12 minus 3, right? So we subtract 12 minus 3, which gives 9 seconds. Hence it had to wait 9 seconds in the job queue to get service. Now P1 arrived at 1st second but was provided service at 3rd second. Hence 3 minus 1 gives 2 seconds. Its waiting time was 2 seconds. P2 was provided service at 6 seconds, 14th second, 20th second and it arrived at arrival time is first one is 2 seconds, second one is 9 second, third one is 17 second. Why is this 9 and 17? Since from 6 to 9 it executed, hence it returned back to the job queue at 9 second, hence 14 minus 9. And it returned its execution from 14th to 17th, hence it returned to job queue at 17 second, hence 20 minus 17, right? It was provided service at 20th second and it returned to job queue at 17 second, so its arrival time becomes 17 second, right? So 6 minus 2, 14 minus 9 and 20 minus 17, which gives equal to 12. In the similar fashion, P3 is equal to 9 minus 3, 17 minus 12. Why 9 minus 3? Because it arrived at 3 seconds, so its arrival time is 3 seconds. Its execution time is, it was provided the processor at 9 seconds, so it's 9 minus 3. And since it executed from 9th second to 12th second, hence it returned to the job queue at 12th second and 17 minus 12 since it was waiting for 5 seconds in the job queue to be executed, right? So 9 minus 3 is equal to 6 and 17 minus 12 is equal to 5. 6 plus 5 equal to 11. Now what is the average waiting time? We add 9 plus 2 plus 12 plus 11. 9 plus 2 plus 12 plus 11 and divided by 4. Since these are 4 in number quantities, hence we divided by the number 4. So 9 plus 2 plus 12 plus 11 gives us 34 by 4, which is equal to 8.5 seconds. Hence the average waiting time is 8.5 seconds, which means each process has to wait on an average for 8.5 seconds to be assigned to the processor, to be given service of the processor. So this is your 8.5 seconds average waiting time. If you found the content useful, then don't forget to click on the like button and please subscribe to my channel for further continuation of this series on operating system and other subjects. Thank you for watching everyone. I will see you in the next video. Take care guys.